Hello students, welcome back to Narayana Digital Classes. Today we will be solving the assignment number 24 on the topic solutions. So let's move on to the assignment. Here the first question. So which of the following aqueous solution will have the highest depression in freezing point? So first, here we need to find, they have given 4 molecules, aqueous solutions. So 0.1 molar aqueous solution and 1 molar 0.1 molar sucrose aqueous solution and 0.1 molar aluminum chloride aqueous solution and 0.1 molar potassium ferricyanide aqueous solution. So among these 4 aqueous solution, which one has the highest depression freezing point? So before going to that, what is the depression of the freezing point? Depression in freezing point. That means we know that freezing point at what temperature the liquid is converted into solid. For example, water is liquid, right? So at certain temperature it will convert into ice. So that temperature, that point is called as freezing point. So if we add some non-volatile solute to this liquid, to this water, for example, if we add sodium chloride, that is common salt. If we add sodium chloride, so in generally H2O will convert into ice at 0 degrees centigrade. At 0 degrees centigrade, when you add NaCl to this H2O, what happened here? The freezing point will change. The freezing point will change. So it will become 0 to minus 2 degrees centigrade or minus 10 degrees centigrade. So the change in this freezing point is called as depression in freezing point. Depression in freezing point. Whenever if you had a non-volatile solute or some other impurities to the pure solvent, the freezing point will change from original freezing point to some other freezing point. So this freezing point is called as depression in freezing point. So generally depression in freezing point is denoted with delta TF. The formula for the depression in freezing point is IKF into M. So here delta TF is depression in freezing point, I is a want have factor. Want have factor. So if a molecule contains more want have factor, so I value is greater, that molecule has the highest depression in freezing point. So how can we find the want have factor for the each and every molecules? So in generally each and every ion contain want have factor is 1. So for example, there is a H plus ion. H plus ion. So H plus ion is there. For this ion the want have factor I value is always 1. If it is Cl minus, I equal to 1. If it is Mg2 plus, I equal to 1. Right? So here we need to find the which of the molecule has the highest want have factor. That molecule, that aqueous solution of that particular molecule has the highest depression in freezing point. So let's see here. Let's see here. First one, urea, right? So generally urea is an organic molecule. It cannot dissociate into ions whenever if you dissolve in the molecule. It only dispersed in a water. So for this kind of molecules also want have factor is 1. So I equal to 1. So when you come to the second option, that is sucrose. So sucrose also a organic compound. Sucrose also a organic, it's a sugar. So its want have factor also 1. So when you come to the AlCl3, so whenever AlCl3 is a salt, whenever if you dissolve in AlCl in water, it will dissociate into ions Al3 plus 3Cl minus. Al3 plus 3Cl minus. So what is the want have factor for the AlCl3? So I equal to A plus, for Al plus 3 want have factor is 1 plus, here Cl minus have want have factor 1, but 3 number of Cl minus are there. So the final want have factor for the AlCl3 is 4. In the same way, what is the want have factor for the K4FeCN6, potassium ferrocyanide? So K4FeCN6 will dissociate into 4K plus FeCN6 minus. So here the I equal to 4 into 1 plus 1, which is equal to 5. So the want have factor for the K4FeCN6 is greater. So that is why the 1 molar K4FeCN6 has the highest depression freezing point. So the correct option is the fourth option. So here we need to remember one thing, which molecule contain highest want have factor, that molecule has the highest depression in freezing point, right? So the correct option is the fourth, that is 0.1 molar K4FeCN6. Clear? Let's move on to the next question. Here the question is, freezing point of benzene is 5.40 degrees centigrade. On dissolving a non-volatile solute in benzene, the freezing point of benzene is depressed by 0.80 centigrade. Computed molarity of solution. Molar depression constant of benzene is 5.1 K molarity inverse. So here we need to find the molarity of a particular solution which has a impurity of solute and the solvent is benzene. So they have given freezing point of this benzene is 5.40 centigrade. So whenever a non-volatile solute is added to this pure solvent, the depression of freezing point has decreased up to 0.80 centigrade. So they have given the molar depression constant, that is 5 K. So we know that depression of freezing is delta TF equal to Kf into M. So Kf delta TF is the depression in freezing point, and this is the molar depression constant, molar depression constant. So it's also called as cryoscopic depression constant, and M is the molarity. So we need to find the molarity of this particular solution. So molarity small m equal to delta F by Kf. Delta F by Kf. So what is the delta F depression freezing point? That is 0.80. And what is the Kf value? That is molar depression constant, that is 5.1 K. 5.1 K, right? If you solve this one, you will get around 0.1568. So which is equal to 0.157. So the correct answer is third option. Let's move on to the next problem. Here the third question, a 0.5 molar solution of ethylene glycol in water used as a coolant in a car. If the freezing point of constant water be 1.86 Kelvin kg per mole, the mixture shall be freeze at, right? So here we need to find the depression in freezing point of a solution which has ethylene glycol in water. So we know that water freezing point is 0 degrees centigrade. Whenever if you add ethylene glycol, that is CH2OH and CH2OH. So this is the ethylene glycol formula. So whenever if you add this ethylene glycol to the water, the freezing point is of the water will decrease. So it may be minus 10 degrees centigrade or minus 10 degrees centigrade to minus 15 degrees centigrade. So we need to find the mixture of that particular ethylene glycol and water depression in freezing point, that is delta TF. So we know that delta TF equal to Kf into molarity, right? So what is the molarity of that particular solution? That is 0.5 molar. And what is the depression freezing constant? So freezing point constant of water will be the 1.86. So Kf, that is 1.86 into molarity 0.5. So if we do the math, we will get 0.93, that is delta TF. Depression in freezing point equal to 0.93, right? Now we need to find the freezing point of constant water V 1.86. So here we need to find the freezing point of the particular solution. So this is the depression in freezing point. So we know that depression in freezing point delta TF equal to freezing point of the solute. So TF of the solute, pure solvent minus freezing point of the solution. Right? Then we need to find the freezing point of the particular solution, that is TF of solution equal to TF of solvent, pure solvent minus delta TF. So here the pure solvent is water. We know that water freezing point is 0. So 0 minus, what is the depression in freezing point? 0.93. So this will be minus 0.93 degrees centigrade. So the freezing point of the particular solution is minus 0.93 degrees centigrade. So the correct option is the second option. Clear? With this, I come to the end of the session. Thank you very much.